Welcome to Lucid Mind Chemistry channel. In this video, I have put together some questions related to the topic Oxidation of Alkenes. For links to other topics and question timestamps, please visit video description. Question 21. Which compound would produce two different carboxylic acids when treated with hot concentrated acidified manganate 7 ions? Now, hot concentrated acidified manganate ions, it breaks the carbon-carbon double bond, so therefore cleavage of double bond takes place. The product formed depends upon the type of this carbon atom that is involved in double bond. If the double bonded carbon is attached with two hydrogen atoms, it will form CO2. If the double bonded carbon is attached with alkyl group and hydrogen, it will form aldehyde and then further form carboxylic acid. If the double bonded is attached with two alkyl groups, then it will form ketone. Let's see what is attached with carbon atom. In this carbon, we can see this is attached with one hydrogen atom and one alkyl group. Similarly, this carbon atom is attached to two alkyl groups. So this part will form carboxylic acid and this part will form ketone. So A is incorrect. In part B, this carbon atom is attached with one hydrogen atom and one alkyl group. Similarly, this carbon atom is attached to one hydrogen atom and one alkyl group. So both these carbon atoms will form two different carboxylic acids. This carbon atom will form this product. We have CH3COOH, while this carbon atom will form this product. We have two CH3 and COOH is formed. As both carboxylic acids are different, so B could be correct option. In part C, the carbon atoms are both attached with one hydrogen and one alkyl group is present. So therefore, it will form two carboxylic acid functional groups present on single chain. The product will be like this. We have 1, 2, 3, 4 carbon atoms in between the chain. And on each end, we have two carboxylic acids present. So single product having dicarboxylic acid is formed, so therefore C is wrong. In part D, again we have one hydrogen atom and one alkyl group on this carbon, one hydrogen atom and one alkyl group on this carbon. As we can see that on both sides we have the same alkyl groups attached, so therefore the carboxylic acids formed will be the same. So D is incorrect. Correct answer is therefore B. Question 22. Compound X can be converted into compound Y in a single step. This is compound Y. We have ketone. We have carboxylic acid. What could be the identity of X? In the product, we can see that we have ketone on second carbon. And we have carboxylic acid on first carbon. As these are all ring structures, so therefore alkene must be, the bond must be broken. In order to produce ketone, the double bonded carbon must be bonded to two alkyl groups. And in order to form carboxylic acid, the double bonded carbon in alkene must be bonded to one alkyl group and one hydrogen. In the product we have 1, 2, 3, 4, 5, then substituent 6 carbon atoms in the long chain. It means that the double bond must be between second and sixth carbon atom. Let's look at part A. We have 1, 2, 3, 4, 5 and then substituent on 5 and then 6. In part B we have 1, 2, 3, 4. Substituent is on 4th, which is wrong because the substituent position cannot be changed. In part C we have 1, 2, 3, 4, 5. Substituent on 5th, and then we have 6 and 7 carbon atoms in the long chain, which is not true because there must be 6. In the last part D we have 1, 2, 3, 4, 5, 6. Substituent is on 6th carbon atom while it should be on 5th. Only one option is left. We have 1, 2, 3 on 2nd carbon atom. We have two alkyl groups. One is this one is this one. So it will be converted into ketone. Yes, it has converted into ketone. Then on 5th carbon atom we have methyl functional group. This is also true. Then on 6th carbon atom we have one hydrogen atom, one alkyl group, so this is oxidized into carboxylic acid. Correct answer is therefore A. Question 21. Compound L has the molecular formula C10H16. A sample of L reacts with an excess of hot, concentrated, acidified potassium manganate. Compound M is produced. What could be the structure of compound L? In the structure of M, we can see that this part is ketone, as this carbon has two carbon atoms attached directly. This carbonyl carbon is also from ketone, while this third is carboxylic acid functional group. In options A, B, C and D, we can see that there are two types of bond. One is single covalent bond and the other is double covalent bond. And single covalent bond is not oxidized by hot concentrated acidified potassium manganate. Only double bond is oxidized. So for oxidation of alkenes, you should remember whenever an alkene is having two alkyl groups with double bonded carbon, so this will convert into ketone. If one of the group is alkyl in alkene and the other group is hydrogen with the double bonded carbon atom, then this will convert into aldehyde. And it is further oxidized to carboxylic acid. If the double bonded carbon atom has two hydrogen atoms, then it is converted into CO2. Now looking at option A, we have this carbon which is making a double bond, and this carbon has two alkyl group attached. So therefore this bond will break and this carbon will make a ketone. This carbon has a double bond and it has one alkyl group and one hydrogen atom attached. So this will convert into aldehyde and then carboxylic acid. We have two more carbon atoms with double bond. One is this. It has two alkyl groups directly attached. So upon oxidation, this bond will break and it will convert into ketone. This carbon has just two hydrogen atoms attached with it, and upon the breaking of double bond, it will convert into carbon dioxide. In B we can see this carbon atom makes a ketone. This carbon atom will make carboxylic acid as discussed in the previous one. This carbon atom has one alkyl group directly attached and one hydrogen atom. So this will first convert into aldehyde and then into carboxylic acid. This carbon is also making double bond and it has one alkyl group directly attached. So it will first convert into aldehyde and then into carboxylic acid functional group. In part C, we have this carbon which is making double bond. And this carbon has one alkyl group directly attached and the other is hydrogen atom. So upon oxidation, this double bond will break and this carbon atom will convert into aldehyde first and then go into carboxylic acid. Again, this carbon atom also has a double bond and one alkyl group directly attached. The other element is hydrogen. So it will also first convert into aldehyde and then further oxidize into carboxylic acid. Now this carbon atom has two alkyl group directly attached, so it will convert into ketone. And this carbon atom has two hydrogen atoms attached with it, so it will form carbon dioxide. In part D, again we have this carbon and this carbon. Both will convert into carboxylic acid. This carbon and this carbon. These both will also convert into carboxylic acid functional group. In the structure of M, we can see we have two ketone functional groups and one carboxylic acid functional group. So in these four options, you can see that we have two ketones and one carboxylic acid functional group, which is just made by the structure A. So therefore A is the correct option. Question 23. Which compound would produce a carboxylic acid and a ketone when treated with hot concentrated acidified manganate 7 ions? As we can see that in A, B, C and D we have alkene functional group that is present. For alkenes, you should remember that when reacted with hot concentrated acidified manganate 7 ions, the double bond is broken. And the products can be formed like this. If double bonded carbon is bonded to two hydrogen atom, then the product will be carbon dioxide upon oxidation. If the double bonded carbon is attached with one hydrogen atom and one alkyl group, it will be oxidized first to aldehyde and then further into carboxylic acid functional group. Again, if the double bonded carbon has two alkyl groups attached, so it will be oxidized into a ketone. Let's find out the products. In A, this is broken as we have two hydrogen atoms, so this will form CO2. And as on this carbon atom we have one hydrogen atom and one alkyl group is attached, so therefore this portion will form carboxylic acid. So no ketone is formed, so A is incorrect. In B we can see that this bond will break as this carbon atom has one hydrogen atom and this also has one hydrogen atom and one alkyl groups are present on both carbon atoms, so both will form carboxylic acid functional groups. So B is also incorrect as no ketone is formed. Similarly in C we can see that this double bond is broken and we have two alkyl group with this carbon atom and two alkyl groups are present with this carbon atom. So both these double bonded carbon will convert into ketone. So we have two different ketone products. So C is also incorrect as carboxylic acid is not produced. Now in D we can see that this double bond is broken and this carbon consists of two alkyl groups. So it will form ketone. And this second carbon, it consists of one hydrogen atom and one alkyl group, so it will form carboxylic acid. As both carboxylic acid and ketone are formed, so therefore D is correct. Question 22. An organic compound X reacts with hot concentrated acidified potassium manganate to give a single carbon containing product. What could be X? You should know that hot concentrated acidified potassium manganate breaks double bond completely. And different types of products are formed based on the reactant involved. Let's look at the options. In A we have CH2 carbon and then two methyl groups are attached with the second carbon atom. So A will be like this. There is a double bond present between first and second carbons. Now when this compound is reacted with hot concentrated acidified potassium manganate, what happens that this double bond will break completely and two different products are formed. This carbon will make CO2 and this carbon will be converted into a ketone. In B we have CH3, CH, CH3, so there is a double bond between second and third carbons. Let's draw the structure of B. Again the double bond will be broken completely, and as both sides of this double bond are symmetric, so we would have 2 moles of CH3, C double bond OH, so it is an aldehyde. In C we have CH2, CH, CH2, CH3, so the structure will be like this. Again on oxidation this double bond is broken and two different products are formed. The first carbon will convert into a carbon dioxide and second will convert into aldehyde. In D we have CH3, CH2, CH2, CH3. So therefore this is an alkane and there is no double bond present. The structure will be like this. And in the presence of hot concentrated acidified potassium manganate, oxidation will not occur. So B is the only organic compound that gives single carbon containing product. Question 38. Limonene is found in lemons. This is the structure of limonene. We have alkene functional group. Also another alkene functional group is present. Limonene is heated with concentrated acidified potassium manganate 7. So what will happen that oxidation of alkene will take place, which compounds are produced. The carbon atoms involved in double bond is this one. As this carbon is attached with two alkyl groups, so it will convert into ketone. This is the second carbon that is involved in double bond, as it consists of one alkyl group and one hydrogen atom. So it will convert into carboxylic acid upon oxidation. Third carbon that is present in double bond is this one. It also consists of two alkyl groups directly attached, so third will convert into ketone. Fourth carbon atom present in double bond consists of two hydrogen atoms and then it will convert into carbon dioxide. So we have carbon dioxide as an option. Let's draw the product that is formed upon oxidation. So this carbon will convert into ketone as this is first carbon. This is the second carbon. It will convert into carboxylic acid. This is the third carbon atom, and it will convert into ketone. And this fourth carbon atom will convert into CO2. Now we can rewrite this skeletal formula into structural formula, starting from this carbon, which is CH3, then we have carbonyl carbon, CO, then we have CH2, then again CH2, then we have this carbon which only have one hydrogen atom attached, so it is CH, and this whole group is attached with this carbon which is C double bond O CH3. So we can write CO CH3. Then we have this carbon which also has two hydrogen atoms, so it is CH2. Then finally this carbon atom which is carboxylic acid. As only one carboxylic acid is formed, while in this one we can see that two carboxylic acids are given, so one is wrong. Third one is exactly the same as the structure given. So 3 is formed. As both option 2 and 3 are correct, the answer is therefore C. Question number 22. But1-ene and but2-ene are treated separately with cold dilute acidified manganate ions. 4 students make statements about these alkenes and the diols formed from them. So first, let's find out the structure of but1-ene. We have double bond on the first carbon atom, and rest are the hydrogens. For but2-ene, we can draw the double bond is on second carbon atom. Both of these react to form diols. So the diol formed will be like this. OH group on this carbon atom and OH group on this carbon atom, and the double bond is converted into single bond like this. And with the but2-ene we have oxygen atom and oxygen atom, and also double bond is converted into single covalent bond. So we have two different types of diols. Now primary alcohol and secondary alcohol can be described as this. Primary alcohol means that the carbon attached with the OH group is further attached to only one carbon atom directly. While the secondary alcohol means that the carbon atom directly attached with the OH group must be attached with two carbon atoms. So this one is primary and this one is secondary alcohol. W says one diol contains two primary alcohol groups. So we have this one as primary alcohol, and this is not primary, this is secondary alcohol. In the second compound we have secondary alcohol and secondary alcohol. So this is wrong. X says one diol contains a primary and a secondary alcohol group. So this is correct because the first but1-ene consists of a primary alcohol group and also a secondary alcohol group, because this carbon is further connected directly to two carbon atoms. So this is correct. Y says one diol contains two secondary alcohol groups. This is true for but2-ene because we have two secondary alcohol groups attached. So this is also correct. And Z says Both alkenes exhibit cis-trans isomerism. So but1-ene does not exhibit cis-trans isomerism because double bonded carbon has two similar hydrogen atoms attached with it. I can draw it again. Now you can see that this double bonded carbon has two similar atoms, so this cannot have a cis-trans isomerism. So this is wrong. So the answer is part C. Question number 23. A molecule of geraniol is shown. You can see that we have two double bonds and one hydroxyl group attached at the end. What is formed when geraniol is added with excess of cold dilute acidified manganate ions? So you have to remember that whenever cold dilute acidified manganate ions is added to an alkene, what happens that diols are formed on the double bonded carbon atoms. Diols means two OH groups. Each on the double bonded carbon atom. There is no effect of cold dilute acidified manganate on the OH group. So we can see that the double bond is converted into single bond and diols are formed. So we have two OH group on this bond and double bond is converted into single one. Same as for the second double bond, we have two OH groups attached with the double bonded carbon atoms and double bond will be converted into single covalent bond. There is no effect on this OH group. Let's move towards the options. In option A, we can see that two OH groups are attached. Also, double bond is converted into single bond. Again, two OH groups are attached and double bond is converted into single bond. And OH not affected. So therefore, correct option is A. Question 22. Maleic acid is used in food industry and for stabilizing drugs. It is the cis isomer of butene dioic acid and has the structural formula. This one, we have alkene functional group, we have carboxylic acid functional groups. What is the product formed from the reaction of maleic acid with cold dilute acidified manganate 7 ions? Now you should know that cold dilute acidified manganate ions, they convert alkene to diol upon oxidation. Diol is the one in which each carbon atom making a double bond is attached with OH group. So this is the product that will be formed for alkene, while carboxylic acid will be unchanged. So for this compound we can see that we have C double bond O, OH on one side, then we have carbon hydrogen, double bond, then carbon hydrogen, then again carboxylic acid functional group. So upon reaction with cold dilute acidified manganate ions, what will happen that this double bonded carbon will be converted into diol. So the product formed will be OH on this carbon atom, double bond converted into single bond, OH on this carbon atom. We can also write the formula like this. We have CO2H on one side, then we have CH, OH is as a substituent, then again we have CH, OH is acting as a substituent, then we have CO2H. Now we can see that this product is exactly similar to the one given in part A. Question 22. An alkene reacts with hot, concentrated, acidified potassium manganate 7 to produce a single organic product as shown. This is the product that is formed. What is the structure of the alkene? Now we know that hot, concentrated, acidified KMnO4 can break the double bond in alkene to give the product. The product depends on the type of carbon atoms involved in the double bond. For example, if the carbon atom present in the double bond is attached with two hydrogen atoms, so it will convert into carbon dioxide upon oxidation. If the double bonded carbon is attached with one alkyl group and one hydrogen atom, it is first converted into aldehyde and then further oxidized into carboxylic acid. In third case, if the double bonded carbon is present with two alkyl groups directly attached, so it will be converted into ketone functional group. Let's find out what products are formed. This carbon atom is attached with two alkyl groups, so it is converted into ketone. This carbon atom is attached with one alkyl group and one hydrogen atom, so it will be converted into carboxylic acid. The product form will be like this. Where this CH3 is this one and this COOH is this carbon. Now in the product we have 7 carbon atoms in the long chain and methyl group is attached with the 4th carbon. While in the compound shown we have 6 carbon atoms in the long chain and methyl group is attached with the 3rd carbon. So A is incorrect. For compound B, we can see that this carbon atom is attached to one alkyl group and one hydrogen atom, so it is converted into carboxylic acid, and this carbon atom is attached to two alkyl group, so therefore this is converted into ketone. The product formed will be like this. This is the first carbon atom which is converted into carboxylic acid, and this is the second one that has converted into ketone. Again we can see that in the long chain we have 7 carbon atoms, whether in the product it shows 6 carbon atoms. So B is also incorrect. Now for compound C, we can see that this carbon is attached with one hydrogen atom and one alkyl group, so it will be converted into carboxylic acid. While this one is attached to two alkyl groups, so it is converted into ketone. The product's form will be like this. The first carbon atom is converted into COOH. Then we have methyl group attached. Then CH2, CH2 and ketone. Now this carbon atom is this one and this is this one. Now we can see that in the long chain there are 6 carbon atoms present, and on second carbon we have ketone, while on third carbon atom no methyl group is attached, while in the given product on third carbon atom there must be a CH3 group present. So C is incorrect. Now in part D, this carbon atom is attached with one hydrogen and one alkyl group, so it is converted into carboxylic acid. And this one is attached to two alkyl groups, so it is converted into ketone. Let's draw the structures. With this carbon we have methyl group attached. Then we have ketone functional group. Now this carbon is this one, and this ketone is given by this carbon atom. In the long chain we have 6 carbon atoms, and on second carbon we have ketone functional group, which is correct. On third carbon we have methyl, which is correct. And on 6th carbon atom we have carboxylic acid functional group, which is also correct. The answer is therefore D. Question 22. Compound X can be converted into compound Y in a single step. In Y we can see we have ketone functional group and carboxylic acid functional group present. What could be the identity of X? In all 4 options we have alkenes. Now oxidative cleavage of alkene can take place to make product. The carbon that is present in double bond, if it is connected to 2 alkyl groups, it will form ketone upon oxidation. And if the carbon atom present in double bond is connected with 1 alkyl group and 1 hydrogen atom, it will be converted into aldehyde first and then into carboxylic acid. As 1 carboxylic acid is formed and 1 ketone is formed, so let's see which is the correct option. In A we can see we have this carbon atom which is attached to 2 alkyl groups, so it will convert into ketone. And this carbon atom which is attached with 1 alkyl group and 1 hydrogen atom, so it will be converted into carboxylic acid. Now we can do numbering. If this is first carbon, then this will be second carbon. On second carbon methyl group is attached, then third carbon, then fourth, and on fifth carbon atom we would have ketone. Let's do the numbering on this product. We have first carbon which is carboxylic acid, then on second carbon we have methyl, third, fourth, and on fifth carbon atom we have ketone, and there are 6 carbon atoms in total. So A seems to be correct option. In B we can see that we have this carbon atom which is attached to 2 alkyl groups, so it will form ketone. And this carbon atom is attached with 1 alkyl group and 1 hydrogen, so it will be converted into carboxylic acid. Now let's do the numbering. If this is first carbon, then we have methyl group attached with the third carbon atom, which is incorrect because methyl group should be attached with the second carbon. Similarly in C we can see that this carbon atom is attached to 2 alkyl groups, so it will form ketone. This is attached with 1 hydrogen and 1 alkyl group, so it will form carboxylic acid. This is the first carbon, second, and on third carbon we have methyl group. Again this is incorrect because methyl group should be on second carbon. Similarly in D we can see this carbon is attached to 2 alkyl groups, so it will form ketone. This is attached to 1 alkyl group and 1 hydrogen atom, so it will form carboxylic acid. If this is first carbon, then we have methyl group on second carbon. And there is no ketone on fifth carbon atom. And there are 7 carbon atoms in total long chain, so this is also incorrect. Correct answer is therefore A. Thanks for watching. If this was useful, please do like, subscribe, and share.